Okay, we're looking at the first year core textbook, mixed exercise 8, and we are on binomial expansion. So write down the first 4 terms of this binomial expansion. So they haven't labelled this one as an exam question, but it certainly could be. And it's quite a good question. It sort of throws up all the things to be careful of. So that fraction, that x over 5, we're going to need to take care of. Okay, so you do get the binomial expansion formula. So let's try and get this on the same screen. Yay. Okay. So for us, A is 2, B is x over 5, and n obviously is 10. So my first term, and you really don't want to have to be looking up this formula and substituting everything in from scratch each time. You do need to be really familiar with it, but it certainly obviously doesn't hurt to have it in front of you. So my first term is going to be 2 to the power of 10. So that's my a to the power of n. And then from 10, choose 1. That is just going to be 10. So if you've already put that, then that's fine. The power of 2 is going to reduce by 1 each time. So this will be 2 to the power of 9. And I would tend not to write multiplications because it can just then it just makes your answer longer and harder to read when you're simplifying it. And then I get b. So for us, b is x over 5. I'm going to use brackets there. Okay, so then it's going to be 10 choose 2. It's going to be 2 to the power of 8. And b is going to get squared. And do I need more terms? First 4 terms, yeah, I wish I'd written a little bit smaller. Okay, never mind, so I'm going to come down to the next line. So then it's going to be 10 choose 3. The power of 2 is going to reduce to 7. And x over 5 will be cubed. So it is absolutely essential that I have brackets around those terms. They're not essential for the x over 5, but I would put them there anyway, just make it a bit easier to read. So let's then simplify that, because I think this is probably the point where mistakes start to creep in. So let's go through them term by term. So 2 to the power of 10, well, that's easy enough, isn't it? That's just going straight into my calculator. So that's 1024. So then it's 10 choose 1, which is just 10 times 2 to the power of 9. Okay, so the 10 choose 1 times 2 to the power of 9 is giving me 5,120. And then that's also divided by 5. So you can either do that as times a fifth or divided by 5. Obviously, that's the same thing. So that gives me, for instance, that would be 1024 again. So that's 1024, and that's obviously my x term. Okay, so then moving along, I'm now looking here. So in my calculator, I'm just going to type in 10, choose 2, and then I'm going to multiply that by 2 to the power of 8. So that's giving me 11,520. And then this is probably the first bit where you need to be really careful. That fifth is going to get squared. So that's going to be times a fifth squared or divided by 5 squared, or divided by 25, however you prefer to type it in. Okay, so that is giving me 2304 over 5. You can put it as a decimal as long as it's an exact decimal, which this one would be. I would probably just leave it as a fraction. Okay, and then the last term, just squeeze it onto the same row. Okay, so I've got 10 choose 3 times 2 to the power of 7. So that is giving me 15,360. And then that is going to get divided by 5 cubed, or times by a fifth cubed. Okay, so that, I'll check my answers in 1 second. So, can I scroll right? No, I can't. Okay, so that will give me 3072 over 25, and that's my x cubed term. And that does count as the first 4 terms. Yeah, it's not up to the 4th power of x, so that does count as your first term. Okay, right, and then part B, I think they're asking us to find approximation. Yeah, okay, so this is quite a common second part to the question. Okay, so all I need is to see that expansion. Okay, so you've just expanded 2 plus x over 5 to the power of 10, and now they're talking about finding approximation for 2.1 to the power of 10. So these questions are only going to work if those are to the same power. So first thing I can do is say, well, look, if they're both to the power of 10, then really what they're saying is we want 2 plus x over 5 to equal 2.1. So if I minus 2 from each side, I want x over 5 to equal 0.1. So if I multiply up, x is going to, sorry, if I multiply it by 5, x is going to be 0.5 or a half. And the point of this type of question is they should give you a value of x that's relatively straightforward to substitute in. I'm going to use my calculator for sure, but technically I could substitute 1.2. I could substitute a half back into this expansion without using a calculator if I had to, because that's obviously going to be a quarter and that's going to be an eighth. But I'm not going to, I'm not going to, I'm just going to go use my calculator. So, but I do still need to show some working. So 2.1 to the power of 10 is approximately equal to 1024. So I'm just looking back up at my expansion, which we can just about see. Move up a bit, let's move this out of the way. Okay, so 1024 plus 1024 times x plus 2304 over 5 times x squared plus 3072 over 25 times x cubed. Okay, and then that's fine for my working. I'm using the wiggly equal lines because obviously this is an approximation. So I'm just going to carefully type all that in. And so the last bit, so 3072 over 25 times half cubed. Okay, so I'm going to check this against their solutions. If I was doing this in exam, I would probably type that in a couple of times, maybe try and type it in a couple of different ways as well. And it doesn't really make sense. So normally we'd say, oh, leave your answer as an exact fraction if you can, but obviously that's only an approximation anyway. So it really doesn't make sense for me to leave that as an exact fraction. So I'm going to change it to a decimal, and then I'm going to round that to 3 significant figures because that's what we normally go for. I'm just going to double check what they've made of that. Yeah, okay, so they've sort of given the full thing. I would certainly write the full solution down to sort of show I had worked it out. And then they've also, they've given their coefficients there as decimals. I'm going to be happy that ours are the exact equivalents because we've got the same answer there. So I think we're good.